So question 7. Show that x minus 2 is a factor of 2x cubed minus 3x squared minus 3x plus 2. So we're going to use synthetic division to solve this. So we start off by writing 2x cubed minus 3x squared minus 3x plus 2. Now you can take the factors out, so it's 2 minus 3 and 2. Okay, and we're told that we want to show that x minus 2 is a factor. So x minus 2. So we can set this equal to 0, so therefore x is equal to 2. Okay, so let's use our synthetic division here. So that's a 0 here at the moment, and there's a 2 here. So 2 plus 0 is 2, times by 2 is 4, plus minus 3 is 1, times by 2 is 2, take away 3 is negative 1, times by 2 is negative 2, negative 2 plus 2 is 0. So I need to write a statement here. So since the remainder is 0, x minus 2 is a factor. Okay, and then you get your 2 marks for using synthetic division correctly, and then you get your second mark for interpreting the result. So for part B, or part 2 even, hence factorize fully. So we've already know that x minus 2 is a factor, right? And we're left with this quadratic term here. So when you do the synthetic division, this is going to come down and become a quadratic instead of a cubic. So you're left with 2x squared minus plus x minus 1. Okay, now we just need to factorize this term here. I'll not even make this very explicit, so this comes from here. So now we need to factorize this. So x minus 2, right, I'm going to put 2x here and another bracket here. So 2x squared can only come from 2x times x, and then for minus 1, our factors are going to be plus 1 and minus 1. So we have plus 1 here and minus 1 here. So you can even just check it in your head. So 2x squared goes to 2x minus x minus 1, and 2x, that will cancel out 2 plus x. So that is correct. Okay, so there are our 3, that is our term fully factorized here. So you get the mark for stating the quadratic and for completing the factorization. Okay, now on to part B. To a new page. So part B, the fifth term u5 of a sequence u5 equals 2a minus 3 in terms of the sequence satisfies the recurrence relation un plus 1 equals aun minus 1. Show that u7 equals 2a cubed minus 3a squared minus a minus 1. So basically what they're saying is repeat this twice and show that you get this value here. So we're told u5 equals 2a minus 3, and we also told that un plus 1 equals to an, or a a un minus 1. So u6 is going to be a u5 minus 1, which is the same as a 2a minus 3 minus 1. You multiply this out, 2a squared minus 3a minus 1. It's going to be the same idea for u7. So a, then you put in your previous result, 2a squared minus 3a minus 1 minus 1. So this then becomes 2a cubed minus 3a squared minus a minus 1. Okay, and that is the same as here. So we just put, you put, as proven. Just underline that result there, and that's worth 1 mark. So now we're moving on to part C, and we're told for this sequence it is known that u7 equals u5 and that a limit exists. So we're asked to determine the value of a. So how can we do this? Well, Ci. So what we need to do here is put these two equations equal to each other. So we have, I'll write it out first, u7 equals u5. So u7 is equal to 2a cubed minus 3a squared minus a minus 1, and that is equal to 2a minus 3. So now we're going to move all these over to one side, set equal to 0, and then we're going to factorize it. So it becomes 2a cubed minus 3a squared minus 3a plus 2. Now you should be able to recognize this from before. It's exactly the same. Instead of a's, we've got x's. So we've actually already factorized this, so we can just go ahead and use our values from before, which were x minus 2 and 2x minus, well, they weren't x, let's remember this is a now. A minus 2, 2a minus 1, and a plus 1. And this is all equal to 0. Okay, so now we solve for a. So a is equal to 2, a is equal to 1/2, and a is equal to -1. So now we need to decide which values, which is the value for a. Well, we know here that in this expression a, we know that since a limit exists, a is going to be 1/2, because it has to lie between the -1 and 1. Like the absolute value of a must be a proper fraction, and it must lie between these two values of -1 and 1. So that rules out these two. Right, and that is your final answer. So your marks come from equating the two equations here. Then you get another mark for solving the cubic here, and then you get your third mark for knowing that it must just be this value here and discarding the other solutions. So part C, CII, for 1 mark, has to calculate the limit. Well, we know that un plus 1 equals a un plus b, and now that we know the value of a, we can go un plus 1 equals 1/2 un minus 1, and that's just from our expression over here. Now we can use our formula for the limit, which is just L equals b over 1 minus a, which becomes minus 1 over 1 minus 0.5 or a half. So this just then becomes minus 1 divided by 0.5, which is the same as saying double it, so it becomes minus 2. So the limit is -2. And that's it, and that's your 1 mark for stating that.